Greetings everyone. In this video tutorial, we will talk about pointers in C++ and this is the second part of this tutorial. We will first talk about reference variables. A reference variable is a name that acts as an alias or an alternative name for an already existing variable. So already existing variable, if we have a variable, now it can be referred by two names. The first name which is given to this variable, and we can also give another name, a reference name to this variable. The syntax for creating a reference variable is we first give the data type, then we give the ampersand symbol, then we give the name of the reference variable and we put equal to and then the name of the already existing variable. Now let us understand it by an example. Suppose we have a variable num of type integer with value 10. So you can see here a memory of 2 bytes will be allocated to num and the value 10 will be stored here. Now if I say int ampersand sum is equal to num. So in this case sum is a reference variable of type integer and it is referring to num. The statements mean this, and so sum will also refer to this memory location to which num is pointing. So now this memory location is known by two names, sum and num. Both of them, they refer to the same memory location and any changes made to the sum will also be reflected in num. And any changes made in the num will also be reflected in the sum because both of them, they are referring to the same memory location. Usage of reference variables. This method helps in returning more than one value from the function back to the calling program. Earlier you have already read that function can return only one single value, but with the help of reference variable, we can return more than one value from a function. When dealing with large objects, reference arguments speed up a program because instead of passing an entire large object, only reference needs to be passed. So we are not passing the large object, we are only passing the reference. Now let us see how how a reference variable can act as a function argument. Let us understand it with the help of an example. Suppose we have a cube function in which x is a reference type parameter of type int, and here we are calculating the cube of x and storing it in x itself. Now in main we have one variable y of type integer with value 10 in it. You can see in this diagram, this is main and this is cube function. In main there is a variable y and it has value 10. So when I say cout y, it will display 10 because the content present in y is 10. Now again in the next statement I am calling a function cube and I am passing y as a parameter. So in this function call, here x is not a normal variable, it is a reference variable. So no separate memory is allocated to x. It will share the same memory as that of y. You can see here no memory allocation has been done for x. It is referring to the same memory as that of y. So when I say x is equal to x into x into x, that is I am multiplying the value of x by x 3 times, that is the value will become 1000. So this value will be changed in this memory location and this memory location is also shared by y. So ultimately the change is reflected in y also. Whatever changes I am making in x, they are reflected in y also. So when I say cout y, it will now display the current value which is 1000. Although I am not passing any value using this function, I am not returning any value, but using a reference variable, this value will automatically be reflected in whatever changes we are making in a reference variable in a function, they will always be reflected in the actual parameter also. Now let us consider a program to return by reference. Now function can also return a reference. In this case, a function call can appear on the left hand side of an assignment statement. Now let us consider a small program. Again I am using a cube function. This time I am returning a reference of type integer and this is int ampersand x, that is it is a reference variable, and again I am calculating the cube of x and I am returning x, and it is not a simple variable, it is a reference variable, you can see here. Now in main I am creating two variables, y is equal to 10 and num is equal to 5. You can see here this is my main and y is 10, this is y, and num is 5. So when I say cube y is equal to num, now you can see this as I'm returning a reference, I can give my function call on the left hand side of the statement also. Otherwise, this function call will become invalid if it is not returned by reference. So in this case, first the function call will be performed. So the function will be called, and again y is the actual parameter and x is a reference. So no separate memory, you can see here this is the function cube. No separate memory is allocated to x. It will share the same memory as y. So in this function, I am calculating the cube of x. So the cube of x will be calculated and the value will become 1000, and this value will be returned as a reference. When we are returning as a reference, I am actually sending the reference of x, which is nothing but y. So in this case, this function call will be replaced by y. So this will become y is equal to num. So now you can see it is equivalent to y is equal to num. As a result, value of y will become equal to 5. We can again try to understand this. This function call, as I'm returning a reference, I'm not returning a value. So in this case, the function call is replaced by the reference which I am returning. As x is referring to y, so this function call will be replaced by the variable y. So this call will ultimately become y is equal to num. So the value of y will become equal to num, and the value of num is 5. So y will also become 5. So when I say cout y, 5 will be displayed, and when I say cout num, again 5 will be displayed. Now invoking functions by passing the pointers. When the pointers are passed to the function, the addresses of actual arguments or parameters in the function, in the calling function, are copied into formal arguments of the called function. So the addresses of actual parameters, they are copied to formal parameters. That means in the called function, whatever changes we make in the formal arguments, the actual arguments also get changed. That is, the changes made in the formal parameters are also reflected in the actual parameters. This is because formal arguments contain the address of actual argument. That is, they point to the memory location where actual arguments are stored. Now let us consider a program in which we are passing by pointer. Now this is a program of swapping two variables, values of two variables with the help of pointers. Now let us see this program. This is a function swap in which I am passing, which has two formal parameters, and both of them are of pointer type. You can see int star m and int star n. And in this is a swapping step. I am creating a temporary variable, and I am storing the value of m in temporary variable, and then value of n is stored in m, and then the value of temp is stored in n. In this way, the value gets swapped. Now in the main program, I am declaring two variables, a is equal to 5 and b is equal to 6. So you can see this is my main program. So a has value 5 and b has value 6. So when I say cout value of a and b. So this will be the output. The value of a is 5 and the value of b is 6. Now I am calling the function swap, and as formal parameters are of pointer type, I will send the address of a and address of b. Instead of simply passing a and b, I will pass the address of a and address of b. So in the function call, we can see here m will contain the address of a, that is it is pointing to a, and n will contain the address of b, that is it is pointing to b. So when I say int temp is a temporary variable. So in the beginning, temp is equal to star m. Star m means nothing but 5. It means the value stored at the address of a, that is 5. So temp will contain 5. And when I say star m is equal to star n, so star n is nothing but the value stored at address of b, which is 6. So m will contain 6. So here 6 will be stored. And when I say star n is equal to temp had the value 5 earlier. So n will also contain value 5. So this is how you can see the value will change. A will now contain 6 after this operation, and b will contain 5. So if I give the cout statement, after swapping values of a and b, I will get value of a as 6 and b as 5. You can see I can easily change using pointers. I can easily swap the values using pointers. Now let's compare pass by value, pass by reference, and pass by pointer methods. There are three types of methods, and it is very important to understand the difference among the three. Now in pass by value, separate memory is allocated to formal parameters. However, in pass by reference, formal and actual parameters share the same memory space. In pass by pointer, formal parameters contain the address of actual parameters. You can see here in pass by reference, they are the formal and actual parameters. They are two different names of the same memory space. However, in pass by pointer, formal parameters contain the address of actual parameters. Now in pass by value, the changes done in formal parameters are not reflected in actual parameters. However, in pass by reference, changes done in formal parameters are reflected in actual parameters because both of them they are referring to the same memory space. And in pass by pointer also, the changes which are done in the formal parameters they are also reflected in actual parameters because formal parameters they are containing the address of actual parameters. Let us understand all the three methods by an example. So let us take an example of the cube function again. This is void cube int x. Here I am passing, this is x is a formal parameter and this is passed by value. So I am calculating the cube of x and in main I am creating a variable y and assigning value 10 to it. So if I say cout y, 10 will be displayed. And if I call the function cube, so y and x you can see here, you can see the diagram. In the main, y is a variable and it has value 10. And when I call the function cube, x will be allocated separate memory space. So all the calculations are done in x and the value of x will become 1000 and y will remain unchanged. So you can see if I say cout y again after calling the function cube, 10 will be displayed. Now let us talk about pass by reference. Again the function and main both are same, but instead of passing pass by value, here x is a reference. So let us understand. So when I say cout y, the first output is 10 and let us call the function y. You can see here in the main y is a variable which has value 10 and when the function cube is called, the variable x is a reference to the variable y. It is referring to the memory of y only. So whatever changes I am making in x, I am storing the cube of x in x, that will be stored in the same memory location as that of y. So after calling the function, if I say cout y, 1000 will be displayed. Now let us talk about the third type in which I am passing by pointer. We can see here this is my pointer type and to calculate the value I have to dereference it. This is a pointer variable x. So star x into star x into star x. Now when I say int y is equal to 10, so cout y it will display 10. Now if I call the function cube, in this I have to pass the address of y. So I am using the address of operator. So when this function is called, we can see in this diagram, this is main and this is the variable y. Now in the cube function, x is a pointer variable and it contains the address of y. That is, it is pointing to y. So whatever changes I am making in x, that is I am calculating the cube of it. So that will be made in the same memory location because I am referring to this memory location only, which is the location of y. So whatever changes I have made, they are reflected in y also. So if after calling the function, if I say cout y, the output will be 1000. This is how all the three comparing pass. This is how we can compare pass by value, pass by reference, and pass by pointer. Let us see how functions can return pointers. The general form of prototype of a function returning a pointer is data type star function name and then we give the argument list. And let us understand it with the help of a program in which we are trying to find the minimum of two numbers using pointers. So in this is a function min and I am just returning a pointer. You can see int star means I am returning an integer type pointer and then I am passing two variables as reference x and y, and if x is less than y I am returning an address of x, otherwise I am returning address of y. So in the main you can see there are three variables. A is 10, you can see, and it is created at this address. Then b variable is created at this address. You can see here the address and the value stored in it is 20. Then c is a pointer type variable. When I say c is equal to min a comma b, the function min will be called and x is a reference to a and y is a reference to b. You can see here no separate memory allocation is done here. As x is less than y, the statement becomes true and it will return ampersand x, that is address of X. Address which is stored in X. So the address is this address only, which is the address of A. So it will the C will contain the address of A, and when I say the minimum number is star C, so it will refer to the value which is present at this address, which is nothing but 10. So 10 will be displayed. Now let us consider the C++ memory map. In C++ memory is divided into 4 parts, and these are listed as follows. The first part is the program code, and it holds the compiled code of the program. You can see this is the program code. This is the complete memory map of C++. The first part is program code, which contains the compiled code of program. The next part is global variables. They remain in the memory as long as the program continues. So when the program breaks, or when the program execution is over, the global variables, they get wiped out from the memory. Now the next partition is stack. This is stack, you can see. It is used for holding return addresses at function calls, arguments passed to the functions, local variables for functions, and it also stores the current state of the CPU. This is all stored in stack. Then heap, which is very important area. It is a region of free memory from which chunks of memory are allocated via dynamic memory allocation functions. We'll learn about dynamic memory allocation, and this dynamic memory allocation is done from the heap area of memory. Now dynamic memory allocation operators, we will learn this now. C++ dynamically allocates memory from the free store or heap, which is the pool of unallocated memory provided to the program. And there are two unary operators, new and delete, that perform the task of allocating and deallocating memory during runtime respectively. New allocates memory and delete deallocates memory. Now let us learn about new operator. New operator is used to allocate memory of size equal to its operand, and it returns the address of the beginning of the new block of the memory allocated. So example, if I say int star L is equal to new int, so in this the operand is int, so it will allocate memory of 2 bytes, and it will return the beginning address of this block of memory, and this memory address will be stored in the integer type pointer L. The memory allocated using new operator can also be initialized at the time of allocation itself. So how I can initialize it? I can say char star ptr is equal to new char, and then within parenthesis I will write down a, as this is a character value. This will be written in single quotes. So this statement does what? New is an operator. As char is written after it, it will allocate a memory of 1 byte, and it will store a in it, and then it will return the starting address of this memory, which will be stored in a pointer variable ptr. That is, pointer ptr is pointing to this newly allocated memory. Now let us learn about delete operator. Delete operator is used to deallocate memory which was allocated using new. So if we say delete L, this command will deallocate the memory pointed to by the pointer variable L. Now let us understand the difference between static memory allocation and dynamic memory allocation. The static memory allocation, the amount of memory to be allocated is known beforehand in the case of static memory allocation, but in the case of dynamic memory allocation, the amount of memory to be allocated is not known beforehand. It is allocated depending upon the requirement. We don't have to mention the amount of memory which we need beforehand. So memory allocation in the case of static memory allocation is done during compilation. However, in the case of dynamic memory allocation, it is done during runtime. So we take the example. Whenever we say int I, this command will allocate 2 bytes of memory, and it will name it as I, and this is the static memory allocation. This is done during compilation time. And to dynamically allocate memory, we use new operator. So example, suppose we say int star k is equal to new int. So in this case, new operator will allocate 2 bytes of memory and return the beginning address of it, which is stored in the pointer variable k. So this is dynamic memory allocation. The static memory is deallocated automatically as soon as the variable go out of scope. We do not need to deallocate it. But in the case of dynamic memory allocation, if it is created using new operator, it is necessary to deallocate the memory using delete operator. For example, we have to give delete k to deallocate the memory which is allocated to k, to which k is pointing. Now let us see how pointer to structures work. The general structure for creating pointers to structures is structure name star structure pointer. Let us understand it with the help of code snippet. In this, I am creating a structure student which has two variables, roll number and name. And in the main, I am creating S1 as a variable of type student. So you can see here S1 is a variable of type student and it has two members, roll number and name. So if I say scene S1 dot roll number, so some roll number will be stored here, and gets S1 dot name, some name will be stored here. And if I say student stars 2, so in this case stu is a pointer of type student. So a pointer will be created in memory. And when I say stu is equal to ampersand S1, it means address of S1. So stu will contain the beginning address of S1. So stu will start pointing to S1. So if I say cout stu arrow roll number and stu arrow name, it will display the roll number and name stored in S1 because it is pointing to S1. So it is very important to note that S1 is a variable to the structure student and stu is a pointer variable. S1 is a normal simple variable and stu is a pointer variable to the structure student. And the data member of the structure can be accessed by pointer to structure using the symbol, using this symbol. So you can see here, otherwise so we give dot operator, we give the variable name dot and then the data member name. But in this case, when it is a pointer to a structure, we have to use this symbol, that this is nothing but dash and then the greater than sign to refer to the data members, to refer to the members of the structure. Now let us consider how to create pointers to objects. Again the syntax is same. Here we give class name star object pointer. So if this is my class student, suppose, which has two data members, roll number and name, and then there is in data to input the data in these two members, and show data function to display the data which is present in both these members. Now I will create main, in which I am creating S1, which is a normal variable of type object of type student, and then I am creating also a pointer to an object. This is a pointer to object. So when I say S1 dot in data, you can see this is S1. S1 has been created. This is an object. So when I say S1 dot in data, some values will be inputted through keyboard and they will be stored in roll number and name. And when I say stu is equal to ampersand S1, so in this case stu will contain the address of S1. So stu will start pointing to the beginning address of S1. And now I can say S1 dot out data. This will display the data which is present in the variable S1, and to display the data which is present in through stu, to display the same data through stu, because stu is also pointing to S1, I will give the command stu, then this symbol and out data. So this is how I can display the data using stu. So again here S1 is an object of class student and stu is a pointer variable to class student, and the pointer stu can access the public members of class by using this special symbol. Don't forget to use this symbol whenever you are declaring pointer to objects or pointer to structures. Now let us talk about self-referential structures. A self-referential structure is a structure which contains an element that points or refers to the structure itself. So if I give the statement, if I am creating a structure student, I am declaring two members here, roll number and name. So in a self-referential structure, I will create a pointer variable which is of type structure itself. So here the structure is student. So I am creating a pointer variable of type student only. So this is the structure of my structure student. So in this case, these type of structures are called self-referential structures, and this type of structures are used for creating a node in a linked list. Now let us see how we can create dynamic structures. To create dynamic structures, we use new operator, and the syntax is structure pointer is equal to new, and this time we will give the name of the structure. So if the structure is student, which has two data members, roll number and name. So in main, I am creating first a pointer to student, student stars 2. This will create a pointer of type student. When I say stu is equal to new student, so what will happen? This is stu. This is a pointer, and when I say new student, so this much memory is allocated. This memory is defined somewhere in memory, and the beginning of address of this is returned by new, which will be stored in stu. So stu will start pointing to this memory. And when I say strcpy, stu arrow name is equal to comma Ramesh, and stu arrow roll number is equal to 1. So you can see 1 is stored in roll number and Ramesh is stored in name. You please observe that I am using this special operator to refer to the members of the dynamic structure. Very important. So when I say cout stu arrow roll and stu arrow name, 1 and Ramesh will be displayed. A dynamic structure can be released using the deallocation operator. So if I create a structure using the new statement, it is very important to give this statement deletes to, and this statement will deallocate the memory which is allocated by new operator. Now let us see how we can create dynamic arrays. The new operator can also be used to create dynamic array, and the syntax is we give the name of the pointer variable, and then we give new, and then we give data type, and then in square brackets we will give the size. And the example of it will be, suppose I am creating an integer type array. So I will declare an integer type pointer int star array. Then I will give new, and this is an integer type array. So I will write int here, and then in square brackets I will give the size, which is 10. This is a dynamic array, and I can also input the size, first see in the size, and then I can give a variable also here. Size can be a variable. This is a good thing about dynamic array. It is not fixed in size. I can change the size according to my need. Now here array, and in the square bracket 0 will refer to the first element of the array. Array 1 will refer to the second element, and so on. And similarly, we can create a one-dimensional dynamic array using pointers like char star name is equal to new char 20. So this is again a character type array will be created of size 20, and the address of first element will be returned, and that will be stored in the name pointer. Now let us understand the difference between static array and dynamic array. The static array, it is created in stack area of memory. However, the dynamic array, as it is created using new operator, so it is created in heap area of memory. The size of the static array is always fixed. It cannot be variable. But the size of the dynamic array is decided during runtime. We can input the size of the dynamic array also according to our need. The memory allocation is done during compilation time in the case of static array. However, in the case of dynamic array, memory allocation is done during runtime. Now, the static arrays, they remain in the memory as long as their scope is not over. However, the dynamic memory arrays, as they are created using new operator, they need to be deallocated using delete operator. Now, let us understand what is memory leak. A memory leak occurs when a piece or pieces of memory that was previously allocated by a programmer is not properly deallocated by a programmer. The memory which we have allocated using new operator is not properly deallocated. So even though that memory is no longer in use by the program, it is still reserved. Unless or until you will delete it, it remains reserved, and that piece of memory cannot be used by the program until it is properly deallocated by the program. That's why it is called memory leak, because it's like a leaky faucet in which water is being wasted. Only in this case, it is not water, it is computer memory. So we are wasting computer memory for nothing, just because we have forgotten to deallocate the memory which we have allocated using new. So if we look at the very small example of this, suppose we have allocated an integer type memory. We have created an integer type memory, and its beginning address is stored in PTR. And suppose star PTR is equal to 100, means I am storing the value 100 in this memory. Now this code, in this case, I have created the memory using new operator, but I am not deallocating it using delete operator. So the above code resulted in memory leak, because the memory which is reserved using new operator is not freed. So this memory is never deallocated and it is wasted. So please remember to deallocate the memory which you are allocating using the delete operator. So this is all for this video session. If you like this video, kindly give thumbs up, and you can also subscribe to my YouTube channel. Thank you.